So in this problem, we're going to be dissolving another salt in with our quote-unquote insoluble salt. This problem asks us to calculate the molar solubility of barium sulfate, but now I'm going to be adding to it a 0.01 molar solution of sodium sulfate. Now sodium sulfate, I think we all know, is extremely soluble. That sodium in it, according to the solubility rules, makes it basically dissociate to 100%. So I'm going to start off thinking about my order of operation. So first of all, does the barium sulfate react with the sodium sulfate? Well, no. Compound plus compound would suggest a double replacement reaction, but with the anions being in common, there's really not going to be any reason for a chemical reaction. So the second thing to worry about would be, how do these compounds associate with water? So we again talked about that sodium sulfate being very, 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 very soluble. So let's just write out its dissociation equation. I'm going to use a single arrow because we know that this is going to dissociate to 100%. And it's going to dissociate into both sodium and sulfate ion. I also know that if the original material started out as being 0.010 molar, that the concentration of the sodium is also going to be 0.010 molar, and the sulfate is also going to be 0.010 molar. Now let's get worried about that barium sulfate. Barium sulfate is typically considered to be an insoluble salt, but we know now that even though we say it's insoluble, everything's actually slightly soluble. So I will go and write out the equilibrium expression for its dissociation. And we know this is partial. And in fact, we even know that the KSP would be equal to the concentration of the barium ion times the concentration of the sulfate ion, and that value is 1.1 times 10 to the negative 10th. So in order to calculate the molar solubility, ordinarily I would define the concentration of the barium sulfate as X, and then use stoichiometry then to define my ion concentrations so that I could plug them into the KSP calculation and solve. Unfortunately, in this problem, we have a common ion between these two chemicals that are dissociating in the water, the sulfate. Well, according to Le Chatelier, whenever you have a common ion and an equilibrium occurring, this presence of this ion is going to shift this equilibrium. So it actually adds into the concentration of the sulfate and pushes the equilibrium toward this direction. So with the addition of the sodium sulfate, we would expect to see precipitation occurring. We just need to know how badly is that molar solubility affected. So instead of plugging in X for that sulfate, which we know would be a ridiculously tiny concentration, from the last problem, I believe it was 1.0 times 10 to the negative 5th molar. That's ridiculously small. Even if those concentrations added together, with the sodium sulfate's 0.01 molar and the barium sulfate's 0.00001 molar, according to significant figures, the dissociation of the barium sulfate's concentration of the sulfate can't touch this concentration. So this is going to just become the concentration of the sulfate. So now when I define my molar solubility of barium sulfate as X, I really can only determine that now through the concentration of the barium, which I'll also define as X. We're going to want to plug these concentrations in and then solve for X. And in this case, we find that the value of X should be roughly equal to 1.1 times 10 to the negative 8th. So the presence of the sulfate ion dropped barium sulfate's molarity from 1.0 times 10 to the negative 5th 1,000-fold down to 1.1 times 10 to the negative 8th. Very strong, the common ion effect.